Hello, everybody. Thank you very much for joining our GNSS threat timing webinar. It's great to see so many of you interested. We've got over 100 people on this call, so this is great. And I'd like to thank all the speakers for agreeing to speak in what I hope is going to be a thought-provoking discussion. Just before I hand over to Dana, to facilitate the webinar, I just want to go through a little bit of housekeeping. This call is being recorded and will be shared with you all. If I could just ask you to keep your microphones on mute, that'd be great. And the format is really the 6 speakers will speak for less than 5 minutes each, and then we'll open the rest up for a Q&A session so that you can have your questions answered. To do that, there's a Q&A button at the bottom of the Zoom, so that's how you reach out to us to ask questions. So that's it from me for now. I'd just like to hand over to Dana to kick everything off.
Well, thank you, Richard, and thanks for co-hosting the webinar today. It's great being here today on behalf of the R&T Foundation. For the benefit of our attendees, we are a scientific and educational charity, so we endorse no products or services, but we are always eager to participate in informative events like this one. At our foundation, we are great fans of GPS, the Global Positioning System, and more generally of GNSS, Global Navigation Satellite Systems. As hopefully most folks know, the timing signals and services they provide have enabled nearly unimaginable improvements in a wide variety of technologies and applications. And of course, as we continue to push technology forward, timing, which is now overwhelmingly provided by GNSS, is going to be increasingly important. Now, this was acknowledged just last month, by the way, by the U.S. National Security Telecommunications Advisory Committee. That's a group of CEOs and senior executives from major telecom companies here in the US. In a report they sent directly to President Biden, they urged him to fund a national timing architecture just for this very purpose. And I have to say, in a shameless act of self-promotion, they also cited a white paper that our charity published on that topic late last year. As the title of our event today points out, there are many threats to GNSS timing, and we all need to be prepared for when those threats are realized. We also need to ensure that we all have rock-solid timing infrastructure, because timing really is tech infrastructure, to support current applications and provide a good basis for future applications and technologies like 5G, NextG, and autonomy as we move forward. Just a couple examples. We have some very respected authorities with us today to discuss both the threats and mitigations. From Cranfield University, we welcome Dr. Simon Harwood. He's the Director of Defense and Security there and a member of the senior management team. Was also with the international arm of Boeing's Phantom Works, sounds kind of great and spooky, and has been a member of Her Majesty's government in the defense establishment. From the United States Department of Transportation, Karen Van Dyke is the Director of Positioning, Navigation, and Timing. She is the foremost expert in the P&T policy issues within the U.S. government, in my humble opinion. And she has too many honors to mention, including being a fellow of the Institute of Navigation. Leon Lobo is the head of the National Timing Center, which is part of the National Physical Laboratory. Did I get the laboratory right? Was that the right English pronunciation? I would say laboratory normally. He's the technical, before that he was a technical director at Laser Optical Engineering, and he holds a PhD from Loughborough University. Tony Flavin is the manager of strategic research at Kronos, previously worked for British Telecom, also more honors than I care to list. And originally, British Telecom was part of the Post Office Research Department. That's a fascinating bit that I didn't just learn today about the United Kingdom. And of course, Richard Hoptroff, who you've already met. He's the CTO and founder of Hoptroff, a precision timing company that uses fiber to transport timing signals. He has a PhD in physics from King's College London, small institution some of you may have heard of. And he did work there in optical computing and artificial intelligence. So let's start out with Simon to give us kind of an overview of the threats and the background of the kind of context of the area that we're working with here. Over to you.
Dana. Thank you. I appreciate that and appreciate the introduction. Yeah, I think this was set up as me setting up to scare everybody really about the problem that we face. I've got to point out right at the head of this call, I'm not a satellite expert. My job, my academic background is looking at risk and resilience and national security risk assessment, in particular looking at disruptive and emergent technology and what we call, for those in the know, black swan type events, so those sort of unseen events. I think as you've sort of explained well, GPS and other GNSS are used in everything from cellular, as we see in the UK, mobile sort of communication networks, to basic consumer goods, to high-end military systems and stock trading inputs, most importantly. But these systems are vulnerable to attack, attacking its position, the navigational and the timing, as we say, the PNT data through what is effectively electronic warfare capabilities. You have from the state to the non-state actor that's able to do this, and I'll jump into that in a little more depth in a minute, but it can cause significant damage to modern militaries and, most importantly, major economies and everyday consumers alike. And I think what's worrying is with the recent advantages in technology, advances in technology, tools and methodologies for conducting this interference, there's now a higher risk profile for the proliferation of this than there ever has been before. To be very clear, if you remember one thing, GNSS attacks are emerging as a viable, disruptive, strategic threat. That's the key of what we're going to talk about today. As a sort of example to that, quoting a really good report by an organization called C4ADS that most of you will be aware of, back in 2017, 2018, they reported nearly 10,000 suspected incidents of mimicry or spoofing of legitimate GNSS signals in order to manipulate PNT data, affecting some 1,300 civilian vessels in the Russian Federation, Crimean, and sort of Syrian area. And that was in one geographic area in 1 year, 10,000 incidents caused by, well, we'll leave it open to interpretation who was actually doing that. There are, of course, what I'll call legitimate uses of spoofing, and I'll put that in inverted commas, such as for the likes of VIP protection or facility protection, as well as for the military for area access, anti-access area denial. And attacking the GNSS signal and system can take numerous forms, both man-made and natural. You've got 4 forms: carrier jamming, which is narrowband jamming of the signal center frequency; signal jamming, which is broadband jamming of the GPS signal; rebroadcast, which is capture and reboot of the genuine GPS signal with a small time delay; and then GPS spoofing, which is obviously broadcast of higher power fake GPS signals with false positional information. And theoretically, I sort of say theoretically, you could also take out the satellite. And we've seen, just last week, we saw a good article in the Washington Times with the DoD sort of talking about the emergence of Chinese lasers and jammers, and we've seen numerous other countries attacking them. Of course, it's with a constellation, it's not just a single satellite. I think there's, what, 31 or so plus satellites for the GPS constellation. So taking out one probably wouldn't have a huge issue, but nonetheless, there is the issue of taking out a satellite, puts more debris into the orbit, which then takes out other satellites. So it's got a sort of compound sort of effect to it. Of course, Dana's own organization, we talk about Carrington events or coronal mass ejections. And I think Dana's organization quoted that within the next few years, there's a 35 to 45% chance of a coronal mass ejection that would lose GPS as a particular GNSS system for 3 to 7 days, and could cause in excess of sort of $10 billion worth of economic effects. Of course, the weakness of GPS to spoofing is inherent in its design, due to the due to the fundamental elements of the way in which it's being designed, then an attack from a lone individual could be effective, but this is likely to be correlated by the case. For example, the range depends on how much signal and power you can push into the transmitter tender. So larger amplifier, more power, and so on and so on. But just sort of wrapping up to say it's very simple in the public domain to build a GPS spoofer. It's a GPS simulator, or take a Raspberry Pi and a sort of software-defined radio. And you could do that quite locally. Obviously easier for civilian codes and military codes, which are sort of encrypted, but you can still cause a little bit of havoc, say at the local airport or at the local stock exchange or something like that, should you have the knowledge, the will, and the intent to do so. But what I'll leave you with is a vote of confidence that thankfully UK MOD, other government establishments in the US as well, they are on top of this, they are aware of this threat. But I think what we need to be aware of, it is a threat. And like we always knew that a pandemic was a threat, were we prepared for this pandemic? Could GNSS, anti-access area denial, could be that our big, we know it's a threat. What are we doing about to contend, cope with it, and prepare for such an event that we know is highly likely? Dana, I'll leave it at that. Thanks, hope that was useful.
Thanks, Simon. Really good. Appreciate that. So before we get to UK specific things, perhaps Karen Van Dyke, you can tell us what the United States is thinking about this, and perhaps some plans to address the timing issue.
Yeah, thank you, Dana, very much, and pleasure to be part of the panel today. So I think Simon set the stage very well for the concerns that we've had at the Department of Transportation. I was part of the Volpe Center team 20 years ago now that looked at the vulnerabilities of GPS for transportation applications. And of course, back 20 years ago, we were more concerned about jamming, but we knew certainly hypothetically GPS signal could be spoofed, and we included that in our DOT report, and I think that was one of the first occurrences of spoofing discussed in an unclassified report. So of course, a lot has changed over the past 20 years, and Professor Todd Humphreys from the University of Texas at Austin read our report, and we had predicted within 10 to 15 years that the spoofing would become a lot more prevalent, and he certainly demonstrated that with his students in spoofing UT Austin drone at one of the DHS events, and then subsequently a ship in the Mediterranean. And now we've seen with software-defined radios just how easy it has become to spoof the signal. And one additional point I would add to what Simon mentioned, that we've traditionally been concerned about RF measurement spoofing, but we also need to be concerned about data spoofing and thinking of GPS receivers from a cybersecurity standpoint, and the computers that they are, not just radio, one-way, receptions, and some of the, concerns over data manipulation that might occur. So for Department of Transportation, this is something that we take very seriously. I will say up front, DOT is a civil lead for GPS, and we have a great partnership with the U.S. Space Force and are focused on GPS modernization. But at the end of the day, there's limits to what you can do with a weak signal in space. And so we do need to be very proactive in looking at complementary PNT technologies. DOT conducted an extensive demonstration of 11 technologies last year. So that was culminated in a report to Congress earlier this year with a set of recommendations focused on requirements on vulnerability assessment and stress testing of technology. So understanding for other PNT technologies what their limitations are as well, and performance monitoring. And from a transportation standpoint, where safety is always our top priority, and we need reliable PNT across all the modes of transportation. And as we're looking to the future with automated, vehicles. We'll never have consumer confidence in automated vehicles if people are concerned that that vehicle will drive off a cliff or into oncoming traffic. And yet, in the United States last year, we even during a pandemic had 38,000 people lose their lives in auto accidents. And so there's, such an opportunity for technology with P&T at its heart to reduce the number of fatalities and injuries. So for DOT, we're focused on 3 main principles, and these have been developed by the Space-Based P&T Advisory Board, which Dana Goward is a prominent member of, and it's known as protect, toughen, and augment, or the PTA principle. So protect, we want to protect the spectrum. So we continue to use GPS and GNSS, and we want that spectrum protected from any harmful interference, particularly from any authorized sources of interference, but we can't predict what might happen. So we know that the jamming and spoofing threats are there, as Simon discussed. We've seen occurrences of that. So we need to also toughen receivers, look at signal authentication techniques, again, address receivers from a cybersecurity standpoint, but also augment and really embrace complementary P&T technologies. And the final point I'll make is this is so serious that last year the White House issued an executive order on strengthening national resilience through responsible use of positioning, navigation, and timing services. Required NIST, the National Institute of Standards and Technology, to develop what's known as a P&T profile to really assess your risk tolerance and walk through a set of procedures to understand your dependency on P&T and what sources of P&T you should be applying for your particular application, to understand if that level of risk is tolerable, or perhaps you need to take mitigation procedures. So that's something that certainly critical infrastructure is embracing, and we want to have technology options available that can be adopted to ensure P&T resiliency. Thank you.
Well, thanks, Karen. Appreciate that overview from the United States. Now, perhaps our last speaker, because he is a government official, and as a UK government official, he has clearly understood the problem and moved to solve it. Leon, you're responsible for the National Timing Center. So clearly timing is not a problem in the UK. And how about telling us how you have addressed this problem and put it completely to bed for everybody over there in the British Isles?
Excellent. Thank you very much, Dana. And well, thank you for everyone for joining this webinar. As Dana mentioned, we do see the element around the threat to GNSS being quite significant. And in fact, coming out of this current crisis, this pandemic that we're all in, has really resulted in entirely new ways of working. I mean, just this webinar in itself, and we've really moved into that virtual world. Reliance on a rapidly evolving digital infrastructure is only going to increase very significantly as we move forward, as will be the threat landscape affecting it. So we really need to consider how we rely on our digital infrastructure and make sure we protect it moving forward. Now, from the point of view of the P&T capability that GNSS provides, it is to a large extent the ubiquitous service provision that everything to a large extent depends on for its position, navigation, and timing. And that, particularly the element of timing, tends to be very much an invisible utility in this space. So whether it's facing of the energy grid, sync for telecom networks, timestamping in finance, autonomy, as Karen raised, smart cities, and the list goes on. In fact, a large percentage of the use cases require the T in P&T. And more critical really is that time tends to fall in the gap between the cyber and the physical when you look at mitigations. And apart from the signals in space that we raised a whole host of vulnerabilities, Simon raised them earlier, there's the element around the space assets themselves that we ought to consider protection of. And now in the UK, a few years ago, we had published the Blackett report on satellite dependencies for position and time. And some of the key outcomes from that was that there's a significant dependency across critical infrastructure sectors on GNSS for position and time. But more importantly is the lack of awareness of the dependency, as well as the urgent need for resiliency due to this vulnerability and the evolving landscape. There was another report that was raised around the loss of the UK economy being of the order of £5 billion over 5 days. And there was a similar report in the US on this front as well. Remember, that's the failure of today because of the inaction of 10 years ago. What it could look like in the future if you don't do something now, it could be quite significant. And to that extent, the National Physical Laboratory, where I work, we've set up this National Timing Center program to start to secure what is the national capability, UTC NPL being the national timescale, but also start to drive and stimulate the supply chain for products and services in the UK by starting to provide access to signals and consider what those signals could look like in the future as we move towards a redefinition of the SI second, for example. And another element that we are sort of driving now is, apart from the awareness element, there's a whole piece around skills education and training, which is really important because there's quite a sparsity of training courses, degree modules, etc. in this space. So that's something else that we're trying to promote to start to help shape what timing looks like in the future, being able to enable industry, deliver new services, whether it's terrestrial, over terrestrial networks, RF broadcasts, optical line of sight, LEO satellite systems, MEO satellite systems, and the like. Because the last thing we want is that for emerging and future applications to be dependent by default on weak and vulnerable space systems without the mitigation to ensure that they are secure and resilient. So that's the driver really within the UK. It's really around making sure we are aware of the vulnerability and start to consider and implement alternatives to support our future applications. Back to you, Dana. Thank you.
Thank you, Leon. So, Tony, your extensive background in British Telecom, I know you speak at WSTS and ISTF. By the way, that for those of you that don't know and are interested in timing, those are the world's two leading forums on timing and synchronization. I commend them to you both. And Tony is a very a regular participant in those and a leader in the field. So Tony, what kinds of things should Karen, Leon, and the rest of us consider in terms of timing?
Okay, thank you. I think it's not all actually about the space-based segment having a problem. I mean, clearly we should not rely upon GNSS signals where you've got critical national infrastructure type requirements, but that doesn't mean to say you're not going to use them. Of course you are, because they're ubiquitous, it's worldwide, it's easy and cheap to use. But you need to be able to know several things about the performance of your receiver. So such as, is it working at all? Is your antenna good? Antennas cause a lot of problems. So historically in BT, we had receivers fail in the City of London, and it took 3 months to get an antenna replaced, purely because there were peregrine falcons nesting on the roof, and we weren't allowed to go up and fix it. So, you know, so it's not all the big nasty guys overseas who want to do nasty things to us. It can be local things which cause a lot of problems as well. The other thing which can cause problems is the last time we had that satellite outage in the GPS constellation, which kind of took the whole constellation down rather alarmingly. The impact on the ground was that management centers started noticing GPS receivers basically failing or raising alarms. And then so did the next one, and the next one, and the next one. And the alarms were just marching across the country. So as you looked at the control board, it was just going from green to red as the failure noticed across country. It shouldn't have been a problem because the backup systems at that time for frequency only were already in place. But you try stopping the ops guys trying to fix it. So, you know, you need to understand what the failure mechanisms are going to be, which is very difficult because we can't predict all of the failure mechanisms, whether it be physical, deliberate attack or whatever. So it would be nice to have an alternative which you know you can rely upon, and of course that's things which the Blackett report and the equivalents in America have been recommending. You then have to ask two questions: is what do I actually need in terms of resilience and protection? And how deep are my pockets? How much am I prepared to spend on this? And again, to give a quick example, if you're trying to meet 100 nanoseconds holdover, which you're going to need for 5G networks, etc., at a clock source, a good quartz OCXO is going to give you an hour. A rubidium is going to give you 2 hours. A cesium is going to, maybe if you're lucky, give you a day to 10 days. And then you're into hydrogen maser territory. So you're going to need incredibly deep pockets to be able to service these types of requirements. So absolutely really understand what your requirements are, because it's just saying, oh, we need resilience is going to cost you a lot of money if you don't get it right. Having said that, there are applications that do need resilience of a hydrogen maser distributed via fiber or low frequency or whatever else we've got around. It raises as many questions as it answers realistically, but that's the world we've got to move into. And I think that's about me done.
Well, thank you, Tony. And I have to observe at this point that let's see, 1, 2, 3, 4 speakers have talked about awareness, actually, and how important awareness would be. I recall that the Alcoholics Anonymous 12-step program starts with number 1, first you admit you have a problem. So good place to start, but it's still a long way from the 12th step and getting the problem solved. So Richard, maybe you can, happy to have you say awareness as well. It's always a good thing. What are your thoughts about some of the solutions getting us further down the road to step 12?
Well, awareness is certainly an issue. You know, I get people asking me what I do for a living, and you know, I tell people what the time is. It's you know, it's a bit confusing because they don't really understand the importance of that. But I think we've heard from everybody today different aspects of the same problem. You know, our dependency on navigational satellites for navigation and timing is really fragile for many reasons. I'm sorry I didn't touch so much on the space weather, which is quite a concern for me, Dana. But you know, the dependency is deep, and the time synchronization is really central to it. You know, communications, power distribution, financial services. You know, that's just naming a few. I mean, they would actually really struggle if they lost connection to satellite sources. For timing for more than a few hours. So what I'd like to do is just take you briefly through what we've done in financial services to address this, because it's kind of different from what everybody else does, and it is one of the avenues for resilience. So in finance, the 3 big issues are security, cost, meeting regulations. That's it. And to meet regulations, you need to be able to work out what happened when, and so financial institutions need accurate time. So what we did to address this was, rather than just rely on satellites, we built a time distribution network based on internet protocol. And it's actually based on the extranets of telecoms companies such as British Telecom, BSO, Colt, and so on. And we distribute time from New York, London, Tokyo, and synchronize these. We can synchronize a device pretty much anywhere on the planet except Antarctica, actually, because the penguins are holding out on the negotiation contract. But you know, we're getting there. So while we do use navigational satellites, it's really important that we have a time distribution network which is completely terrestrially based. It's all based on IP, and I think this will ensure that we get some kind of fallback option against the delivery of satellite timing. We'll never be as good as GPS. You know, we're at the microsecond level rather than the nanosecond level, but it's enough. It's a fallback option, and so this is enough as far as we're concerned to provide that guarantee to people who need to keep society functioning. This serves financial services very well, not just for regulatory compliance, but you know, just to avoid the downside impacts of failure. You know, even at the basic level, you know, if we lose this satellite connectivity, then after a few hours, payment systems will start to fail. And you know, I don't know where you are, but where we live, it's a fairly cashless society now. So it's pretty much, you know, if I can't just tap my card, I can't pay and pay my way. And this technology we've developed for finance services, I believe, is going to be equally applicable to other industries. So I would just like to point out that these other technologies exist. And our challenge really is just to implement them as alternatives, well, not alternatives, but as fallback options for the satellite timing technologies that are available today.
Great, thank you, Richard. So we have had a couple questions pop up, which are good follow-ons to what Richard mentioned. So and they talk about so what's next? Awareness is good. What kind of systems will these P&T profiles from the executive order and the Blackett report and that sort of thing? What kind of systems and solutions are these going to foster, and which may or may not be implemented? So Karen, maybe I realize that you can't disclose any proprietary or government classified information or pre-decisional information, but maybe you could talk to us, expanding upon what Richard said about fiber, about the kinds of things that you found as a result of your GPS backup technology demonstration.
Yeah, thanks, Dana. So, so as I mentioned, we had 11 different technology vendors participate in our demonstration. A couple of those were time over fiber solutions that performed extremely well and show a lot of promise, and you know, really ties back to the executive order. So that, you know, and I saw some questions in the chat about, you know, we know what the problem is, what, you know, how do we, you know, actually field solutions, and that has been the, you know, the challenge, and recognition that from a US, you know, government standpoint, you know, we don't own the critical infrastructure. You know, we depend on it tremendously from a transportation standpoint, and transportation is one of the designated critical infrastructure sectors within the United States. So that's the challenge. How do we encourage adoption? absent, having a wide-scale disruption that will convince people that they need to do something as soon as possible. And so that is the intent with the P&T profile, is to think through what your requirements are. And I think that was a very important point about requirements, because they are different for various applications, to understand what vulnerabilities you may be introducing into your network, and if that level of risk is higher than what you can tolerate, what options you can do to mitigate that risk, and looking at the solutions that are out there. One part of the executive order also had tasked Department of Commerce, which really meant a NIST to provide a GNSS independent source of UTC, and so they have established a special calibration service that I think a lot of these time over fiber networks can take advantage of, and it's really walking through the options. And of course the executive order can't task these end users other than the federal government, but the education and outreach that we can provide to our stakeholders is really important. And I think highlighting that there are technologies that can be adopted, and it's beneficial to do so, but before it's too late.
Very good, thanks, Karen. And could you cover? I realize it was a demonstration program, but I think you found that there were a combination of technologies in terms of a national approach would be needed to provide a reasonable approach in terms of timing and location backup.
Yeah, exactly, Dana. And so the demonstration confirmed what I think we knew, that having multiple diverse technologies is really beneficial. Of course, we conducted the demonstration in March of 2020, right before everything shut down due to the pandemic. But I think the technology vendors, after having looked at the report and looked at the results of how other technologies performed, have come to the conclusion that if they partner together and take advantage of the various technologies. So we had ELRAN, we had low Earth orbit satellite capability, time over fiber I mentioned, certainly UHF capabilities as well, with metropolitan beacon types of systems, and so I think looking at the combination of technologies and the integration certainly will be good, and that is a key recommendation, is to embrace multiple and diverse technologies.
And thanks for that. And so before I put Leon on the spot with what the UK has done and might be doing, let me remind everybody that we have a short survey to get everybody's feedback. There is a link to it in the chat. And we hope that as you have attended the webinar, you'll fill us out and give us your thoughts so that we can build on them going forward. This is a community effort, after all. Everybody in the timing community. So Leon, I get the impression that the UK is a little bit further down the road perhaps than the US. You have established a series of atomic clock suites around the nation that are linked together by fiber. Is that right?
So as part of the National Timing Center program, we are looking at the resiliency problem for the timescale as a core of what will be the source of resilient time for new dissemination solutions, whether it's a LEO satellite, terrestrial network, or an RF broadcast, by not the element of hardening one solution. It's all about multimodality, diversity, and redundancy towards that goal of resiliency. And similarly, from the point of view of the UK user perspective, the resiliency will come not from hardening one particular solution, but it is about getting access to a diversity of dissemination methods, which have entirely different failure modes. And that is sort of the driver moving forward, where you will have access to a source of time over ELORAN perhaps, or over a fiber network, or from a LEO constellation, but they will all be essentially disseminating the national timescale. And the key piece there is about embedding traceability where it's required. So ensuring that regardless of what mechanism the user gets their time from, they all have that inherent synchronization by virtue of having traceable signals back to the global standard UTC. So there is that element, not just from the point of view of resiliency by virtue of diversity of solution, but also the opportunity by embedding traceability within solutions. So that's you could say the high level, and the way we see it progressing is what we are doing now as securing the national timescale on geographically distributed secure sites is about provision of assured services. So the element of assurance is going to be key as well. So it's not just about providing the time signal, but it is providing the time signal with accuracy at the levels required, with the traceability back to UTC, the elements, the metrics around availability, integrity, security, continuity, etc., such that it is now moving from having a time to having a trusted time and being able to access it across the UK as a utility and no longer an invisible one. That's the vision for the future, basically.
Great. It sounds like a multimodal national timing architecture.
Yes.
So, yeah. So, I mean,
exciting times.
I'm sorry?
Exciting times.
Exciting times, yes. So will all of this be part of the national P&T strategy? I saw a mention of that in the House of Lords, soon to be announced, or perhaps soon to be announced.
Yeah, there's been a huge contingent of people working on that developing strategy. So we should see that soon in the public domain. So
perhaps after that comes out, you'll be able to say more about your different modalities. I'm assuming your atomic clocks will somehow also be able to link to mobile users and that sorts of things.
Yeah, if you consider the segments within from the user community, not from the point of view of sectors, but GNSS will always have a part to play and a significant role to play, because you can segment the users from a global use case requirement for PNT. There's the element of the mobile platforms. So a network delivery is never going to service a mobile platform necessarily. And then you even go down from a mobile platform perspective, you're looking at very low swap devices, so low size, weight, and power, and being able to service those needs. So not one solution will be able to service all those needs. So for example, GNSS can't service the needs for where you don't have access to the sky, for example. And a network couldn't deliver to a mobile platform or to a rural location where you can't deliver a fiber network. So it's a combination of these solutions that will actually provide resilience for the future and really drive opportunity for industry to develop new products and services.
Oh, very good. Thanks. So we have had a number of questions on the box here about LORAN and ELORAN, and I think Tony knows something about that. One of the questions is the report that the LORAN signal in Anthorn may be taken off air. Tony, can you address some of those? I know you can see some of the questions there.
Yeah, I can't actually see that particular question yet, but
okay.
At the moment, the situation of Anthorn is it's still alive and well. I've been checking it on a daily basis now for several years, and the timing signal from ELORAN is at the moment very, very good. There is a support contract for that with the operators of the site, which is due to expire, I believe, end of June this year, so in a few days' time, but I believe that's being extended to December initially, whilst proper funding, etc., is put in place going forward. So that signal is secure in the short term, and hopefully it will be secure in the long term as well, because I think low frequency solutions like ELA-RAN definitely have a place to play here. Certainly because they will provide timing accuracy which is near enough equivalent to GNSS. And I mean, I'm just about including L1, L2 receivers there as well. So 20 to 100 nanosecond type area is fairly easily achievable. You also of course, get position as well, which you don't get from pure timing solutions. That, of course, requires more antennas to be put up, etc., which would require for that type of solution anyway. So yes, I think that the future is looking at those solutions, and I think a solution ELA-RAN or a very similar thing has a definite place to play in the forthcoming resilience story for timing in general.
Well, speaking about terrestrial transmitters, so if you're going to provide time to mobile users, you would need to have a way for them to determine their location independent of the sky anyway, right? Independent of space.
Yes, and again, ELA-RAN could play a part there. For
Right.
mobile users, it's probably slightly easier nowadays because most of the 4G, 5G signals you can triangulate between cell towers, etc. But the cell towers need very precise timing in the first place. So you've got to get precise timing to those cell towers before those other techniques will work at all. So again, it has something to play there. Normally cell towers aren't moving, so at least you know they're fixed, but you've got to get the timing accuracy to them. So otherwise it all kind of falls apart very quickly. And that's going to be particularly important with 5G, because I think nearly all the 5G networks worldwide are going to be TDM based. So if the timing goes, you start wandering into adjacent cells and data crashing, and the whole lot just, it fails very quickly. It fails by falling off a cliff when that happens. There's no nice soft failure modes. So the timing for 5G and presumably 6G and onwards is going to be absolutely critical.
So it goes back around to timing is everything.
Yeah.
Yeah, the foundation of everything. Yeah, very good. So then we have a question about the US-UK and international endeavors. It would be nice if there was an international consensus on the way forward, which very difficult to argue with. Just as we have an international consensus on how GNSS ought to go. Perhaps can anyone speak to the kinds of things that other nations are doing? Leon, how about your friends across the channel there in France? What are they up to?
So not so much, I'd say, in France from the point of view of resiliency, but I'd say every country is considering how the threat landscape is evolving very rapidly. I mean, we've all seen the Black Sea incidents, etc., and how it's proliferating. So there is a marked effort to ensure systems are more resilient. But just from the point of view of collaboration, I think the recent Atlantic Charter that was signed for SNT at the G7 in Cornwall last week, or the week before rather, is going to be quite significant in collaborating between the US and the UK moving forward on new developments, whether it is in the PNT arena or some of the supporting supply chain like atomic clocks, for example, whether it's for clocks for satellites or whether it's dissemination systems for the ground. I think those are the real opportunities coming in the near future, because we all have the same problem. It's not a local or a regional issue. It is a global problem, and it's a global. The solutions will be viable to a large extent. Could be picked and placed into different arenas. So I think there is that opportunity there, not just from the point of view of collaboration, but also supply chain and export and inward investment and the like.
Well, I suppose every issue is a global issue these days, but certainly time is a sovereign responsibility, right? And Just as an example, our universal coordinated time is just slightly different than your coordinated universal time, which is slightly different from the French coordinated universal time, et cetera, and so forth. We all know precisely how much different it is, so we can all align, but it's a sovereignty thing, right? And it strikes me that it's a sovereign responsibility to address ensuring folks have the time as well. Departing a little bit from my moderator role, I will observe that China, who seems to be hot on the track of a lot of things, has not only 3 levels of PNT satellites at GEO, LEO, and MEO, but they are also have terrestrial systems. They're leveraging their 5G network. They're developing autonomous systems with chip-scale atomic clocks and inertials, and they are dead set on having a national time scale that anybody can access whenever and wherever they need it. Perhaps something that other nations should take a look at, if only to narrow the timing gap between ourselves and a competitor, if not adversary. So.
Yes, just on that point, Dana. So UTC is the global timescale. The national realizations like UTC NIST, UTC USNO, UTC NPL are the national realizations of that and traceable to the global timescale. So I don't think that is, they are different in that respect. They're all providing the same, access to the same global timescale, that is UTC.
Fair enough.
Timescale.
Thanks. So a question in the box here about improving satellite-based time in terms of authentication services like Galileo has. Can anyone comment on that?
Not my area of specialty, no, sorry.
Yeah, I guess I'll say a few words. So in the U.S., our recent presidential policy on space-based positioning, navigation, timing, known as SPD 7, does include signal authentication, both for GPS as well as augmentation systems, such as the wide area augmentation that the FAA operates WAS. So it is certainly recognize that it's very important. The analogy we use is for banking and just the 2-factor authentication that's been adopted. And so for GPS, how do you know that the signal is actually coming from GPS or for the augmentation system? So you do want to have that authentication. So DOT is identified as being responsible for those requirements in SPD 7, of course, working closely with Department of Defense and Homeland Security. And so we're just embarking upon that. I would certainly want to leverage some of the research that's been ongoing with various signal authentication techniques, and of course our collaboration with the EU on what they've done for Galileo. But I think we're looking at both in-band and out-of-band techniques. Certainly interested in efforts that are going to take place on the NTS-3 and that'll launch in 2023. And so I think we'll learn a lot from those endeavors. And I think we need to look at what our near-term options are, because certainly incorporating anything onto future GPS satellites is not a quick solution. So again, having capabilities that can be adopted sooner than that is certainly a key area of research.
Thank you, Karen. And just before we wind up here, we had one last question, and it gets us back to kind of the awareness issue. Talking about GNSS interference detection systems. I know that both the UK and the US government have thought a lot about this, and I think the UK government has even put some money to it. Leon, can you comment on that briefly before we go to Karen?
Yeah, there have been some programs in place to start to look at both the detection of events, but also you could say the signatures of those devices, and in order to start to understand how we build better mitigations and the like. So, and Tony, I think, has also been part of some of the detection capability and the networks around that front. So I'd say in the near future, there will be services delivering monitoring capability for the UK, for example, where we'll be monitoring pretty much every broadcast signal for health and for denial or disruption in order to inform the users. And that is a huge step forward rather than some of the local capability that's typically been in place. But it's evolving as it's.
Okay, I thought I'd read that there was a network under contract.
Donna, maybe I could just jump in with a quick point here. There's a chap called Tim Marshall on the questions asked a really good question about, is this something boards? We've talked a lot about the strategic level intervention at governments and what governments are doing. And Tim's question for those that have sort of seen it is this something that boards should be aware of? Is this something that isn't on people's risk registers and something that companies should be thinking about? And as sort of Richard joked before, timing is one of those subjects that people as a risk and then from a resilience perspective just don't really talk about on a daily basis. And I presume a few years ago, nobody in the boardroom talked about pandemics either. I think that the health warning here, we've talked a lot about what governments are doing and government's responsibility. Leon and Karen and Tony and everybody doing a great job building these things. But there are things you can do locally. There are things that you could do within your company. There are things that people should be prepared with and sort of should be recognized against local jamming and spoofing type events against particular services. And, you know, what I keep pushing on is the trialing and testing. We have a thing in the UK called Black Start, where we would switch the grid off and switch it back on if there was a coronal mass ejection type activity. We need to be trialing and testing these things. That's the key. But the first time we reboot the system shouldn't be the first time we've had an attack on the system. We should be doing it before that point. I know these things are in hand, but it's not just the government's responsibility. Companies have to take a responsibility, like the London Stock Exchange, like the airports, and so on and so on. So just thought I'd interject with that. Thanks, Dan.
No, thanks. I mean, that's an excellent point. Certainly was a thrust of the presidential executive order here last year. And no one can argue with folks taking responsibility for their own systems and their own safety. I do make a note, and we'll take that under a suggestion, Karen. We should take this seriously. Simon recommended we turn GPS off for a day, see what happens. So we'll note that down and submit it through the appropriate channels. But
maybe just simulate switching it off rather than actually.
Oh, okay. So my concern is it's kind of like a Y2K thing. You know, you have no idea how deeply burrowed it is into so many systems and until it actually goes away. And
I think that's the problem here. It's the cascade effect of these things, right, that we don't see. You know, the analogy I made before is, who knew the roads, the environment would get cleaner because there was less pollution because of a pandemic? You know, it's those sort of unforeseen type consequences of cascade.
Yeah, yeah. Well, good. Well, let me remind, first, let me thank everybody, especially the folks at Hoptroff, for helping with this, and for all of our participants for a very informative and interesting webinar. I think we could go on for days on this, and I know actually that most of you do go on for days because this is your job. So we thank you for sharing an hour of your day with us and sharing it with everybody in the that is in attendance. Let me remind everybody to complete the survey. Again, that link to that is in the chat. And we look forward to more very constructive and interesting conversations and to seeing how All of this plays out on a local level with individual users taking responsibility or not for their own safety, and governments safeguarding their populations with various systems, policies, regulations, and however they may choose to proceed and take this forward. And let's hope that that it's not a matter of having a massive incident or problem that jolts everybody awake, but we can do it through educational events like this. So thanks very much, and keep well, and look forward to talking with you next time.
Okay, thank you. Thank you very much for attending, everybody.
Thank you, everyone.
Thank you.
Bye.